Well, today we are starting Chapter 6, Solving Systems by Graphing. So first we have to know, what is a system? It's very hard to see, but this says a system of linear equations is either two or more linear equations. So typically a system is written with a bracket like this. You might have a y equals 5x plus 2, y equals 3x minus 8. So those two equations create a system. You could also have more than two because it's or more. So I could also have a y equals negative x plus 4. That makes a system. What is a solution to a system of linear equations? So any ordered pair that makes all equations true. So another way to think about this is if I have a system, and today we're going to be graphing systems, and let's say one graph would end up looking like that, the other graph would end up looking like that. The solution to this system is where the two graphs overlap, because this point is true for both my red line and it would be true for my blue line because this point lies on both lines. So it's basically where the graphs overlap that makes both equations true. So today we're going to talk about solving systems by graphing. So the first thing that you're going to want to do is graph both lines. So when I look at my first equation, my slope here is going to be equal to 1 because there's no number, so no number means 1, and my y-intercept is going to be equal to 2. So my y-intercept is what I graph first, so I look at my y-axis, and I go up 2, and then from that point, I move my slope, so it's up 1, over 1, up 1, over 1, up 1, over 1, or else I could go down 1, left 1, because negative over negative is the same thing. And I'm going to draw that line. It's very important when you're solving systems by graphing, you want to try to make your line as straight as possible. So now I'm going to graph my second equation. So here my slope is equal to 3 because the slope is always in front of the x. Remember, it's not the x including, just the number. My y-intercept is negative 2. So first I plot my y-intercept. So on my y-axis I go down 2. And my slope is 3, so that means I go up 3, 1, 2, 3, over 1. I go up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. So now I have a couple of lines, and or dots. I would always make sure to draw more than 2 dots because when you're solving the system, you want to make sure that you get the correct point here. So now I'm looking at this. There's one dot that I used on both equations, and that's this dot right here. When you are solving by graphing, it will only work if the two lines cross at a corner of the graph. What do I mean by that? So in this case, it crossed at this corner. So this is the point 2, because x goes over 2, and y moves up 4. If for some reason you would graph two lines, and they would cross at a random spot like this, you cannot solve by graphing, but we will get into that later. So this case, my answer is 2, 4. Right now, I want you to copy down this system right here. This is my system. And I want you to solve by graphing to see if your graph matches, or your answer matches the same as mine. So I graphed my two equations, and when I look at my two equations, my solution is where do the graphs overlap? Where do they cross? So they cross at this point because this point is used on both graphs. So that would be my x moved over to the left 2, so that's a negative 2, and y did not move up and down. So this would be my solution, negative 2, 0. Then if I want to check my answer, how do I check my answer? Well, I'm going to use this point that I found, and I want to make sure it's true for both equations. So if I look at my red line, does 0 equal 2 times negative 2 plus 4? Because this is my equation, and I'm plugging in my answer. So if I solve this, 0 is equal to, this becomes a negative 4 plus 4. This works out. That's checking my answer for the first equation. And I want to check my answer to the second equation. So again, I use my equation. Does 0 equal negative 2 plus 2. So using my equation and my answer, I'm checking my answer. So 0 equals negative 2 plus 2 is 0. So both of them check out. So this answer works. So why would we use this system of equations? Well, here's a good example with a word problem. Scientists studied the weights of 2 alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown. After how many months the alligators weighed the same amount? So I want to figure out at what point in time do the alligators weigh the same amount. So I'm going to have alligator 1, and I have to set up 2 different equations here. So alligator 1, let's say, remember rate is always going to be your slope. So I'm going to write up an equation. So I'm going to have my weight, that's going to be my y. My rate is 1.5. If I write that as a fraction, that would be 3.5 x. And my initial weight, what did I start at? That's your b, that's your y-intercept. So now I have my equation for my alligator 1, and now I have to write up my alligator 2. So my total weight is going to be equal to, I have 1 pound per month. Again, rate is going to be the same thing as your slope. So that would be like 1x, and my initial weight was 6. So now I'm going to graph both of my equations. So my first equation goes up 4, and I have a slope of rise of 3, 1, 2, 3, 1, 2 over, 1, 2, 3, 1, 2 over. Here's going to be my line for the first alligator. And then I have my second alligator, so it's a y-intercept because my initial weight was 6. I have a rise of 1, run of 1, rise of 1, run of 1, rise of 1, run of 1, rise of 1, run of 1. So now here's my slope, or my line for my second equation. So here is where they cross each other. So at this point, it is 4, 10. But that's not what my answer is. When you're given a word problem, you have to actually relate, what does this answer tell me? I'm asking it, how many months did the alligator weigh the same amount? So if I look at my equation, my months would be my x, because depending on how many x or months that the alligator was alive depends on how much it weighed. So my answer here would be my x value, which is 4 months. The 2 alligators weighed the same amount. And finally, with systems of equations, there's different answers that we could have. We have an independent answer, and that's what we have been dealing with, where we have exactly one answer with my system. So if I have 2 equations right here, they're going to cross at exactly 1 point. So this would be an example of independent, exactly 1 point. Dependent would be if I had 2 systems of equations, and I would graph one, and it would look like this, and I would graph the other, and it would look like this. Whenever they overlap, that means they're going to have all solutions or infinite solutions because they're basically right on top of each other. And my last one, where it would be no solution, if I were to graph one equation and then graph my second equation, and if they're parallel, so lines are parallel, then they're never ever going to cross. That means there will be no solution. So I want to know how many solutions will I have. I don't know what the solution is. I want to know, will it have one solution, infinite, or no solution? So the first thing I have to do is graph. But before I do that, I have to rewrite this equation so it says y equals. So I'm going to add x to both sides of my equation, and then divide by 2. And when I divide by 2, my slope becomes 1/2, and 2 divided by 2 is 1. So now actually when I look at my 2 equations here, my first equation and my second equation, they look very similar, but I'm still going to graph them. My y-intercept is 1, and then I have a slope of rise of 1, run of 2, rise of 1, run of 2, and I'm going to graph that line. That's my blue line. And my red line, it also has a y-intercept of 1 and a rise of 1, run of 2, rise of 1, run of 2. And then I graph my red line. So when I look at my graphs, they're overlapping. So my answer here would be infinite solutions because they're the exact same line. So last one for the day, how many solutions does this have? So first you graph the two equations. So in this first equation, my y-intercept is a positive 2, and then from that point, I have a slope of a rise of 2, run of 1. Rise of 2, run of 1. I'm going to draw that line. And then my second equation, I have a negative 1 y-intercept, and then a slope of rise of 2, run of 1. Rise of 2, run of 1. And graph that. When I look at this equation, I saw that both of these two slopes are the exact same. That means they're parallel. So there's going to be no solution here. These two lines will never cross. That means there will never be an answer. Make sure you submit your Google form and have a great, great evening.